A frontier lab announced its new flagship model today and did not release the weights. That's the story. Not the benchmarks, not the leaderboard position. The weights are being held for 2 weeks, and the announcement says why, in one sentence, they'll ship once safety evaluation and hardening are complete. For a lab whose entire identity is open weights, a lab that has published downloadable models release after release, that is a genuinely new sentence. And the reason it exists is printed a few paragraphs later, in language I did not expect from a launch post. While scaling up their training, a capability grew faster than they expected. Not coding, security. Specifically, the ability to find flaws in software. So today's video is about 3 things, and I want to be precise about all of them, because this is a topic where sloppy coverage does real damage. First, what actually shipped and what didn't. Right now, this model is available through the lab's own products. The interface, the coding plan, the tools that speak to it. The weights are a promise with a date attached. That gap between announced and downloadable has never mattered before at this lab, and this week it matters enormously. Second, the claim, Decoded. They say this is the best model in the world at one specific security benchmark, better than the strongest closed models on their own comparison list. That's a real claim with a real number behind it. It's also narrower than the headlines will make it, because the same post shows the model losing badly on 2 related tests, and includes a sentence about that gap that is the most quietly remarkable admission I've read in a launch post this year. We'll run yesterday's decoder over all of it. And third, the receipts. They didn't just publish scores, they published a ledger. Thousands of real flaws in real open source projects with a disclosure process attached, some of them decades old. That's the part that actually changes your week if you maintain software. And it's the part I most want to get right. One thing I'll say up front and repeat, this video contains nothing about how any of this works technically, and it never will. No methods, no tooling, no targets. We're here to read published claims, decode a benchmark table, and think clearly about a release decision. That's the job. Plan. What shipped, the engineering story nobody's covering, the cyber claim decoded, the ledger, the 2-week question, who pays, honest limits, and the step back. Standards note. I went through the announcement line by line this morning, including every footnote, and the footnotes on this one are unusually rich, which is the highest compliment I can pay a launch post. Everything quoted is verbatim. Every number is theirs. Let's go. What shipped? And the sentence that isn't in most coverage. Here's the state of play from the post. The model is live in the lab's own coding plan and its agent product, and it works inside third-party coding agents through their developer platform. There's an API change worth noting for anyone integrating. Thinking can no longer be turned off. 3 effort levels, low, high, max, with max the default and their recommendation for coding. If your application currently disables thinking, the post says plainly, change it before you switch model identifiers, or the request fails. A model that will not stop thinking is its own small milestone. And the weights. We will release the weights in 2 weeks after launch, once safety evaluation and hardening are complete. The download page reads, coming soon. So today, the correct description of this model is open weights with a 2-week embargo, not open source available now. I'm being pedantic on purpose because half the coverage this week will get that wrong, and the difference is the entire point of the story. The engineering story nobody's covering, the weights didn't change. Before the security headline, here's the finding that made me sit up. The post's own opening line, verbatim. Scaling post-training is all we did for GLM 5.3. And then, it uses the same base model as GLM 5.2. Every gain comes from post-training. Same base model. The pre-trained weights, the expensive part, the part that costs a data center and months, are unchanged from the previous release. Everything you're about to hear about, every benchmark jump came from what happened after pre-training, reinforcement learning against task environments. Sit with the size of that. On one coding benchmark, this model goes from 4.6 to 28.3. On an agentic software benchmark, 46 to 67. Same base weights. All of it from training on tasks, not from a bigger model. And what they scaled isn't compute for its own sake. It's environments. Simulated jobs the model practices in. Their description of the ambition is the good part. Verbatim. Tasks designed around how engineering and research work is actually carried out in practice, where some represent several days of work for an experienced engineer. Their example, an infrastructure task where the model gets what an engineer gets. Clusters, storage, internal documentation, code bases, experiment results, and has to diagnose bottlenecks, implement optimizations, run experiments, and deliver a measurable speed up without breaking correctness. Then the bottleneck sentence, which is the real insight of the post, as agent capability improves, much of the difficulty in scaling post-training moves from the model to the environment. You need thousands of these practice worlds, each executable and verifiable. Hand-building them doesn't scale. So they built pipelines that synthesize the environments. Research agents mining real work for task patterns, turning them into runnable long-horizon worlds with multi-step dependencies and hidden state. Then a judge agent attempts each task to confirm it's actually solvable. Verifiers are synthesized without access to the reference solution, and a verifier only counts once it passes Oracle, no-op, and unsolved state checks. To their credit, they add the honest coda. These pipelines still require a meaningful amount of human-in-the-loop work. That's agents building the gym where agents train, with another agent checking the equipment isn't broken, and it produces the law of this release. The weights are the athlete, the environments are the gym, and this year the gym is where the gains are. If you've been tracking this channel's argument that the loop and the scaffolding matter as much as the model, here's a lab saying it with a whole release. Same body, new training regime, transformed performance. The cyber claim, decoded carefully. Now the headline, and I'm going to walk it exactly as their post presents it, because the shape matters more than any single number. Their framing, verbatim. As we scaled post-training, cyber capability developed faster than we expected. They added vulnerability analysis data and environments to the training mix, expecting the model to get better at reasoning about flaws. And it did, but the growth surprised them. Their description of what changed, verbatim. The model did not simply become better at identifying isolated flaws. It began to reason across multiple stages of exploitation, forming coherent plans for complete exploitation chains. 3 benchmarks, 3 rungs of the same ladder. Rung 1, discovery. A benchmark that starts from source code and asks whether a model can identify and confirm a real flaw. Here the model scores 84.5, up from 77.2, and the post calls it the best result on that benchmark, ahead of the strongest closed models on their list, which land in the low 80s. That is the claim-making headlines, and on that benchmark, as published, it's accurate. Rung 2, deeper reasoning about real vulnerabilities. Score, 54.4, more than doubling the previous model's 24.4. Enormous self-delta, but the closed frontier sits at 78 and 76.5, so a huge leap and still a wide gap. Rung 3, completing tasks under time budgets. This model completes 105 tasks in the 2-hour budget and 130 in 6 hours, against 29 and 39 for its predecessor. And the closed frontier, in their own table, is well ahead at 181 and 247. Now their summary sentence, and this is the most unusual thing in the post, verbatim. The further up the exploitation chain a benchmark sits, the larger the gain from GLM 5.2, and also the wider the remaining gap to the closed frontier. Capability is growing fastest exactly where we are furthest behind. Read that again. A vendor in a launch post telling you the axis on which they lose and that it's the axis they're improving fastest on. That is not marketing. That's a research note that escaped into a press release, and it earns a lot of trust. So the honest one-line summary of the entire cyber section, which is what I'd want a headline to say. This model now leads at finding flaws and trails at everything that comes after finding them. Discovery is where it's world-class. The rest of the chain, it's climbing. Running the decoder. Because this table earns it. Yesterday, this channel published 5 questions for reading any benchmark table. This post is the best possible test case, and I'll say the conclusion first. This is the most thoroughly footnoted launch table I've read this month. Let's see why. Whose harness? Answered everywhere with a version number. Nearly every row was run inside a named third-party coding agent, Claude Code 2.1.207. With temperature, top P, output caps, context sizes, timeouts, and turn limits printed. That is a recipe, not a rumor. Anyone can rerun it. But here's the catch our decoder is built to catch. One row uses a different harness. The agentic software benchmark was run in a different agent framework entirely, with different sampling settings. Perfectly legitimate. And it means that row is not directly comparable to the rows around it in the same table. 2 harnesses in one grid is fine when disclosed. It's only a problem when it isn't. And this benchmark is now our recurring exhibit. 3 separate vendor tables in 1 week have printed a score on the same agentic coding benchmark under 3 different harnesses with 3 different rosters of rivals. And the numbers land all over the place. Yesterday's law holds under pressure. Self-deltas are measurements, rival gaps are advertisements. Read this post vertically. 46 to 67, 4.6 to 28, 24 to 54, and it's a serious release. Read it horizontally against another lab's table, and you're comparing experiments that share a noun. Same conditions for every row? Mostly, with 2 disclosed exceptions worth respecting. On 2 benchmarks, they say the original anti-cheating checks produced false positives, so they removed those checks and substituted model-based inspection of solutions instead. They printed that. It's exactly the kind of local house rule that makes cross-table comparison invalid and in-table reading fine. And you only know because they told you. Anti-cheating work? Extensive, and this is the part I want other labs to copy. Inside the security benchmarks, the agent is placed in the task container, all version control history is stripped so it can't find the answer in a commit, and network access is restricted to a whitelist of package install domains only, explicitly in their words, to prevent the agent from cheating. Another benchmark blocks unauthorized package install operations with both rule-based and model-based checks. That is a serious evaluation posture published. One genuinely novel condition deserves its own beat. On the time-budgeted benchmark, the budgets are normalized by model speed. They take a published tokens per second figure for each model from a third-party analyst and rescale the time limits accordingly, so a slower model isn't punished for being slow when the question is capability. That's thoughtful. It's also a choice, and the ranking depends on it, and the speed figures come from someone else's measurements, disclosed in the footnotes where a lesser post would have buried it in silence. Who judges? One reasoning benchmark is scored by a rival labs model, named. Another is evaluated entirely by an outside analysis firm, both stated. And one small decoder catch to keep you honest, and them. The post Prose and its table label the same closed model column differently. One name in the paragraph, another in the header. Almost certainly an editing artifact in a fast launch, and it changes nothing about the numbers. But it's a reminder of the habit. Read the Prose against the table, not just one or the other. Tables get built by one person and described by another. Scorecard, using yesterday's 7 habits. They print their losses repeatedly, including the sentence about being furthest behind. They print their conditions exhaustively. They label their in-house benchmark as in-house. They name their judges. They show their anti-cheating work. They flag their removed checks. That's 6 of 7, and the miss is minor. This is what an honest table looks like, and it comes from the lab whose model is being accused in the same week of being dangerously capable. Those two facts belong in the same sentence. The ledger. The part that actually affects you. Now the receipts, and this is where the story stops being about a leaderboard. The post says that since the previous model, they've been working with security teams to run these models against real open source code bases. Their figures, after expert review, screening, and deduplication, 2,436 vulnerabilities across 269 projects, including 1,097 medium to high severity issues, the affected surface, in their words, system kernels, operating systems, browser engines, open source infrastructure, web applications, and network protocols. And they built a public disclosure ledger for it, which is the right instinct, and the part I want to praise loudly. It tracks each finding through the disclosure process, distinguishing what's already public from what's still under embargo, and for disclosed issues, it records the project, the severity, the identifier where one exists, and the detail that stopped me, how long the flaw had been sitting in the code. That last field produces the number of the week. Their published breakdown. Over 2,000 findings still under embargo, several dozen publicly disclosed so far. A severity split running from about 100 critical through nearly 1,000 high. And the age, the oldest flaw they found was introduced in 1981, and on average, a vulnerability had lived in the code base 26.6 years before discovery. 26 years, not obscure code, kernels, browsers, protocol implementations, code that has been read by thousands of humans, audited, fuzzed, shipped everywhere, and a language model, working through a systematic process with expert review on top, surfaced flaws that had been quietly present since before most of the people using that software were born. 2 honest reactions, both true at once. The optimistic one, this is defense at a scale that has never existed. Human security research is scarce, expensive, and doesn't scale with the amount of code the world produces. If machine-assisted review can genuinely surface decades-old flaws in critical infrastructure and get them fixed through a disclosure process, that is one of the most straightforwardly good applications of this technology I have covered on this channel. The sober one. These are the vendor's own numbers with their own review process, and identified is doing work that only the disclosure record can validate over time, which is precisely why publishing the ledger matters. It converts a claim into something checkable, slowly, in public by the affected projects themselves. Watch that ledger, it's the real scoreboard here. And a note for anyone whose next thought is practical. The only code you should ever point tooling like this at is code you own or are explicitly authorized to test everything about this story. The embargo, the expert review, the staged disclosure exists because the same capability is neutral about which direction it points. The professional norms around this are not bureaucracy. They're the whole difference between research and harm. The 2-week question, so back to the sentence we opened with. Waits in 2 weeks, once safety evaluation and hardening are complete. What's genuinely new here isn't the concern. Labs have discussed cyber capability for years. It's that an open weights lab is doing a staged release and saying the quiet part in the announcement. The capability outran the expectation, so the download is held back while they evaluate. Closed labs delay things all the time. Nobody notices, because there was never a download. When a lab whose brand is the download adds a 2-week gap, that's a new kind of release note. And I'd argue, a preview of a norm that's going to spread. 2 honest observations about what a delay can and can't do, and I'll keep both at the level of policy, not method. It can buy time for the parts that genuinely help, finishing internal evaluations, coordinating with the projects in that disclosure ledger so fixes land before capability spreads, and preparing the guidance that ships alongside. Those 2 weeks aren't theater, they're logistics with real defensive value. What a delay cannot do is make an open weights release conditional forever. Once weights are public, they're public. That's the deal open weights makes, and it's the same deal that makes them valuable. Anyone in this field will tell you that safety behavior added at the end of training is far more durable in a hosted model, where the vendor controls the sampler, than in a file anyone can modify. That's not a knock on the lab, it's the physics of the format, and it's exactly why the 2-week evaluation happens before rather than after. Which leaves the real question, and it's a policy question rather than a technical one. What should the standard be for releasing weights that are state-of-the-art at finding software flaws? There's a serious argument that defenders benefit most from open access. Maintainers of small projects can't buy frontier API budgets, and the code that most needs review is often the code nobody's paying to protect. There's an equally serious argument about which side of the ledger gets more leverage per unit of capability. I don't think this channel gets to settle that in a paragraph, and I'd be suspicious of anyone who claims to. What I can tell you is that this release is the first time an open weights lab has publicly priced that tension into its own launch schedule, and how those 2 weeks go will shape what the next lab does. Who pays? Standing rule. This one's mostly transparent. The model is available now inside the lab's own subscription and agent product on a points-based quota, with usage counted separately for input, cached input, and output, and a half rate for off-peak hours outside a weekday afternoon window in their home time zone. There's a promotional quota boost through the end of the month, and their agent product advertises a very high cash hit rate, which stretches the same quota further. No figures on this channel as always, but note the shape. Quota systems with peak pricing are what you build when demand is real and capacity is the constraint. And the strategy is the familiar one, executed well. The weights come later and free. The plan and the agent product are the business, and their training framework is open source. Megatron on one side, SG Lang on the other, which is genuinely useful to researchers and also makes their stack the obvious place to do this kind of work. Give away the gym, sell the seat at the machine. Honest limits. 5. 1. Every number in this video is theirs. The scores, the ledger totals, the ages of those flaws, the environment pipeline, all vendor published, none independently reproduced. The footnotes are excellent, which means the coding rows are genuinely rerunnable by anyone with the harness and the budget. The security rows are harder for outsiders to check, which makes them the ones to hold most loosely. 2. The weights aren't out. Nobody outside has run this model unsupervised. Every claim here is about a hosted system today. The open weights version arrives, per the post, in about 2 weeks. And this channel will read the license and the card when it does. 3. I did not test anything and won't. No security work happens on this channel. This is a reading of a published announcement, its table, and its footnotes. 4. The comparison rows for rival models come from this lab's own runs, in the harnesses they chose, on the rosters they chose. The self-deltas are the trustworthy part. The horizontal placements are their claim, and they'll be relitigated by independent runs within days, as they always are. 5. Nothing here is security advice, and nothing here describes how any capability works. If you maintain software, the useful takeaway is boring and real. Watch that disclosure ledger for your dependencies and keep your patching current. Step back because this launch sits at the intersection of every thread this channel has followed this month. The pre-trained weights didn't move, the training environments did, which is the same lesson we found in harness after harness, arriving now at the level of a flagship release. Capability increasingly lives in the loop, the environment, and the practice, not only in the parameter count. A lab published a table with its conditions, its judges, its removed checks, and its losses all printed. The receipts culture spreading exactly as we said it was. And a company that built its identity on downloadable weights just put a 2-week gate in front of one, in public, with the reason attached. That last one is the piece I'll be thinking about all week. For 2 years, the open versus closed argument has been fought over quality. Can open weights catch up? This post quietly changes the question. On one narrow, consequential axis, an open weights model just posted the best published number on the board, and its makers responded not with a victory lap, but with a delay and a safety review. The interesting frontier is no longer whether open models can reach frontier capability in a domain that matters. It's what a lab does in the 2 weeks after they realize they have. So here's my question, and I'll pin it below. Should weights that are state-of-the-art at finding software vulnerabilities be released openly? And if yes, with what conditions attached? Stage disclosure first? Coordination with affected projects? Nothing at all because defenders need it most and gates only slow the people playing fair? I want the actual argument, not the slogan. And if you maintain open source code, say so in your comment because your view carries extra weight in this one. This is a genuinely hard question, and the comments under this video are going to be more valuable than the video. Every link, the announcement, the disclosure ledger, their training framework, the benchmark hosts, and yesterday's Decoder video, whose 5 questions we just ran on a live table, is in the description. Read the footnotes yourself. They're the best part of the post. That's the standard here. The announcement actually read, the claim narrowed to what's supported, the losses reported alongside the wins, the mechanism deliberately left out, and the hard question left open instead of answered cheaply. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.